Hi guys, welcome to the last session of actually it's the last part of the location strategy video. So this is the last calculation part, which is the center of gravity method. So as I recall in the previous video, which is the third part, we were talking mostly about the cost and volume analysis. And then before then, we talk about the factor rating. So these are the three methods. You will see that based on the objectives of what you want to achieve as a business owner or as an entrepreneur, you will decide which method works for you. If, for example, you're just a small business that would like to start somewhere, I mostly recommend factor analysis because that one is just based on factors that you identify as very important. If you are a manufacturing company that is really producing a lot of item and you're thinking about which one to relocate, the cost and volume is really important because you want to look at the cost and you also want to look at the production. Now, the center of gravity method here, it is a method that is mostly used by companies that own distribution centers, which means they already got some retail shop, where they have some stores left and right, and then they are looking for a place where they are going to get the main distribution center to be located. Now, this method is a little bit different. It used finding the best location for a single distribution point that serves different other stores. Now, the method is you need to find it called center of gravity, and it mostly work with how do you call this, a map version. But obviously in this stage here, there's no need for me to, I will do some drawing, but even without the drawing, as long as you understand the principle, we don't do the drawing. But right now I'm just gonna do them for you to understand where we sit at, and then you can take it from there. So anyways, the formulas is, the purpose is to find from a map the x and y coordinate of the distribution center based on the data that is given to you. Now we're going to take a basic example in the test book. Let's look at which one. Sure. Okay, we will look at 8.20. So 8.20 says the following table will give a map coordinate and a shipping load for a set of cities that we wish to connect through a central hub. So we have these locations here. We have the x and y coordinate, and then here we have the load, which means that from city A, for example, the first store, it is located like this on the map, and then this is how much you need to go to that unit. B, this is the second item, this is the second store, this is the coordinate on the map, and this is how it works. So this is the information that we have. The next part says that now near which map coordinate should the app be located if the shipment from city A triples. How does it change the coordinate? So let's try to look at the information first here. So as we got whatever information that we have here, the very first point is I'm gonna try to draw them, but just like I said, it is not really compulsory, but I just want to make sure that we are all on the same level and we all understand what is required from us. So this one is a center of gravity method. So with this one here, the purpose is like we have the city, we have the location in terms of coordinate, and then we have as well the load. The load is the number of units that are being shipped from one place to another. So this one I'm gonna call the area, then here I have the location, and then after the location, then I will have the load. Then here we have location A, B, C, D, E, F, then we also have G. Then in terms of location, we have 5 and 10. After 5 and 10, we have 6 and 8. After 6 and 8, we have 4 and 9. We have 9 and 5. Then we have 7 and 9. Then we have 3 and 2. Then finally, we do have 2 and 6. Now we need now to look at the load here. Just like I said, the load is the number of units that are moving from one place to another, or that are actually coming in that particular area where we have a distribution center. So we have 5, we have 10, we have 15, we have 5, we have another 15, I think. So we have 15, 5, 15, then we have 10, and then we have 5. So the very first question is about, so the location here, these are the coordinates on the map in a format of X and Y. So the very first question is about finding the location, the central location of of this item, I mean, or of the distribution app. I'm just going to draw them for us to understand, but this is not, you don't need to make the drawing. Actually, you can as well, but the best thing is just that if you do it on the calculation, it will make it a little bit very much easy for you. So I'm going to draw a grid line, and then based on that, we'll just use it to draw our items here. Just gonna do some basic drawing, then based on that we can decide if it makes sense. So we have this, then we have this. So we assume that this is a map with the X and Y coordinate. Yes. So I'm going to, as I'm looking at the map here, most of the item is 5 to 10, so the maximum is 10. So I'm gonna try to look here and try to draw something. So 1, 2, 3, 4. I'm gonna just keep 4 as a unit of measurement. Okay. So after 4, we have 1, 2. So I have 1, 2, 3, 4. You can go this one, which is 5. This might not be accurate, but I'm mostly doing this just to allow you to get a perspective of how it looks like. And probably there must be an easy way to do it, but I'm working forward. So I think this is the best way I could find. 1, 2, 3, 4, 5, 6, 7, 8. Then we'll put a 9. Then we'll put a 10 here. So this is, as we are drawing, we know that the horizontal line is the x-axis, and then the y-axis is the one that is on top here. We have taken 4 as a unit of measurement for 4 square. So here we have 1, 2, 3, 4. 1, 2, 3, 4. Yes, like this. We'll start from here. Then here we have 1, 2, 3, 4. Okay, I'll put it like this as well. 1, 2, 4. Then we do the same thing here until we reach 10. This is 3, then we have 4. 2, 3, then I have 4. Let us try to see. 1, 2, 3, 4, 5, 6, 7. So we'll try to add 3 more. This is then we have this. Then the last one is supposed to be this one. Yes. Anyway, so from here, what we are going to try to do, we'll place this point, this coordinate on the map. The first one, it is 5 and 10. So if I assume that this is 1, 2, 3, 4, 5, it goes up all the way until 10. Let me look. So 10, right? I'm gonna put a dot to make sure that this is the allocated place. So if this is 1, 2, 3, 4, 5, 5 is x, and then we go up all the way until we reach 10. 10 is supposed to be somewhere here. So this is where I'm gonna put my item here. So we assume that this is where we're gonna have A. So I'm gonna try to draw an A here. The shape format here, the outline is no outline, and then the fill, let remove. So whatever we got here right now is A, but I'm gonna try to write it as well, so it is 5, 10 like this. I'm gonna try to reduce the font so that we have something that makes more sense. Yes, so this is A. Then the next one that we'll try to draw right now, it is B, which is 6 and 8. So if I go down here, I have 1, 2, 3, 4, 5, 6. I go here, then 8 will probably be somewhere here, because this is 8 and this is 9. So I'm still gonna take the same dot here. So if we are 6, it's somewhere here. This is 3, 4, 5, then 6. 6 is somewhere here. Then we can say this is B. So based on what we have here, I would say B is 6 and 8. Then I go up again and I look at the other one, which is C, which is 4 and 9. So let me try to get this. So 4 is somewhere here. This is 1, 2, 3, 4. 4 is somewhere here. Then if we have to go to 9, 9 is somewhere here. So just like I'm saying, it's not really accurate, as you can see, but we just try to get a perspective of what is just expected here. So we say it's C, it's 4 and 9. So I'm on C, 4 and 9, which is 4, and this one is 9. Then I'm looking at D, which is 9 and 5. So 9 is going to be on X. That's mean 1, 2, 3, 4, 5. This is 10, this is 9. And then we sit 9 and 5. So I have 1, 2, 3, 4, 5. So it's somewhere here. Then I assume this will be a D. We say it is 9 and 5. So we have D, which is 9, and we also have 5 here. And apart from that, we also have, yes, then we look at E. E, it's 7 and 9. So as I look down here, 7, so 7 is this is 1, 2, 3, 4, 5, 6, 7. Then 9, we go a little bit up, then we'll be somewhere here. Actually, it's on the same level as this one, which was 4. But this one here, we would have 7 and 9. This is 4, 5, 6, 7, and 9. Yes, but this one is E. Then as we go from E, we have F, which is 3 and 2. So I'm trying to look at my 3 here. 3 is 1, 2, 3. We are here. So 4, then it is 1, 2, 3, 4. So we are sitting here. Okay, try to put it like this. Then this is going to be F. F, we say, is 3 and 4. So if we are here, oh, we said 3 and 2. Sorry. So we have 1, 2, 3, and then this one is going to be 2 somewhere here. 3 and 2. And the last one is G. Then G is 2 and 6. So I'm here, and I have 2. If I go 1, 2, 3, 4, 5, then I have a 6 here. Then whatever I have is a 6, is a G. G, we say it is 2 and 6. Now, when we have this, the objectives of this method is about finding a center of gravity, which means we need to find the location where we are going to get a distribution center. A distribution center means we have these all shops, they still belong to the same company, but we need to find a place on this map where we're gonna allocate the distribution center so that it's gonna be a place that will minimize the distance of each one of these locations. So let's go back to the calculation. For now, I'm going to remove the grid line. So the formula, we need to find x and we also need to find y. So what I'm going to do is, okay, we're just going to try on your page. Okay, so this one and here. So based on the formula in the test book, what we have to do to find x, so we actually need to find x and we need to find y. Y and x will be the coordinate of the new distribution center. So I'm going to insert an equation here, and I'm mostly going to put the values instead of putting the numbers. So down here, you will put the sum of all your loads, which means that these are the loads. These are the units that are being moved from one place to another. So this is what you get on the numerator. So I'll get 5 plus 10 plus 5 plus 10 plus 15 plus 5 plus 15. So 5 plus 10 plus 15 plus 5 plus 15 plus 10, then plus 5, plus 10, then plus 5. So these values that I've taken here, it is just the load that I have here. Now the next stage on the numerator, what I will do is I will open many bracket. The very first bracket is I'm going to take all the x coordinate of A times the load of A plus the x coordinate of B plus the load of B plus the x coordinate of C times the load of C plus the x coordinate of 9 plus the load of 5. Then we take as well plus the x coordinate of E plus the times the load of 15. So let's go back. To make actually things easier, the method is I put 5, you close the bracket, you open the bracket again. We're gonna put the second coordinate, so which is, we took 5, then we'll take 6, 4 down here. So we have 6, I close this, 4, I close this, and I open again. So I have 5, 6, 4, I have 5, 6, 4, then I'll have 9, 7, 3, 2. 9, 7, 3, then I'm going to have a 2, like this. Now these are the x coordinate of all the location that we have here. These are the x coordinate. Then what you will do is, like, you will take every x coordinate times the load of that that particular coordinate. So site, so we have the site which is B, we'll take the x coordinate which is 6 times 10. This one we get 4 times 15. This one is 9 times 15. So what makes it easy, I have the denominator already here. So I'm gonna have 5 times 5. This is the first load that I'm having here, plus 6 times 10 plus 4 times 15 plus 9 times 5, and then plus 7 times 15. Then I have 3 times 10. Then I have 5 times 2. 2 times 5. Now these values here are just coming from the weight that we already have here. Then based on that, you will do the same principle when it comes to y. So when it comes to y, the denominator is still the same. That means the value that we have here is still the same, except for the location, for the coordinate. So we're gonna go back here and we will look at the coordinate of the y coordinate only. This means here we'll get 10 times 5 plus 8 times 10 plus 9 times 15. So let's go back. So we'll have 10 here. 10 is the y coordinate times 5. Then as I go, the other one is 8 times 10. And after 8 times 10, I got 15. 8 times 10, so it's 9 times 15. And then after 9 times 15, 9 times 15, so I'll have 5 times 5. 5 times 5. And then here I'm supposed to get again a 9 times 15 just for me to confirm. Yes, it is 9 times 15. Then we got 2 times 10. Go down here, I got 2 times 10. Then I go up again here, I do 6 times 5. Here I have 6 times 5. Then once I got all these values, whatever value I'm going to get, that is the value that will give me the correct, the correct location. So let me just check with my calculator. 4 times 15 plus 9 times 5 plus 7 times 15 plus 3 times 10 plus 2 times 5. Then I get the value that is going to be divided by the sum of your value that you get, which is 5 plus 10 plus 15 plus 5 plus 15 plus 10 plus 5. Hopefully I'm not mistaken, because right now I got 5,15, which is at this rate, I will try to round it because it's like this. I just want a whole number for this one particularly. So what I'll just do, I'll just write 5. I'll take 1 decimal, but depending on the instruction of which assessment you're doing, if you are told to use 2 decimal places, 3 decimal places, you will use that one. So on this case, we still do the same thing here. So I will have 10 times 5 plus 8 times 10 plus 9 times 15 plus 5 times 5 plus 9 times 15 plus 2 times 10 plus 6 times 5. Then we divide by 5 plus 10 plus 15 plus 5 plus 15 plus 10 plus 5. So I might be mistaken with my calculation as well, hopefully not, but I got a 7,31, and I'm going to try to round out to 7 here. So this means, please, you can also confirm in the comment section as I'm just doing this live, but again, yes, we stand to be corrected in case we are mistaken. So we have a value like this. This means the distribution center coordinate is we'll have 5 and 7 here. So now that's why we call the method the center of gravity. We call it the center of gravity because what did I say? Distribution, yes. Now it's 5 and 7. Now let me go back to my map here. So I'm gonna look for a point here. We said 5 and 7. So I'll have 1, 2, 3, 4, 5. Then I'm going a little bit up. Let me actually activate my grid line. Yes. So here I have a 1, I have a 2, 3, 4, 5, 6, 7. So between bracket, this is where the distribution center is going to be. Now I'm gonna call it distribution center. I'm gonna call it DC, which stands for distribution center. And the distribution center here, we say it is 5 and 7. So I'm gonna put this in red. Then this one as well will be in red. So this means, in another word, that as we have a company that will that have many other branches, and they would like to open a distribution plant, the best location will be on the map at 5.7. Obviously, this is most of a graphical method. So even as you are working, you need to get all this coordinate. Now with the evolution of technologies, you can just get the exact coordinate through Google Map, and that's where you get your data. But now there are many constraints. Obviously, as you are working here, there are many things that you are not considering. Remember, these are just pins that we are putting on the map. Keep in mind that they can fall in a park, they can fall in a river, they can fall in different areas. Obviously, you'll try to adjust to the closest possible. But these are just of the assumption we believe that whatever coordinate we have here is the actual item on the map in real life. So this is how one use the distribution center. The center of gravity method. Yes, I hope I didn't make any mistakes in my calculation, but should I have made some mistakes, I'm really sorry about that already. Please feel free to leave them in the comment section. But in a nutshell, this is how one uses this method. So as you realize, we have done 3 methods. You will know that all those 3 methods are different. They differ on the size of the company, they differ on the objective of the company, like I explained in the beginning of the video. Should you want to go for just a casual business, it's your first time opening, best to go for a factor rating method. You are going maybe for a big manufacturing company that you manufacture quite a lot of items, it is best for you to go for the cost and volume. But here you have many branches already that are installed, all you just need is a distribution center. It is best to go for the center of gravity method. So in a nutshell, thank you very much. That is it about this chapter, and I can't wait to start a new series with you. Thank you so much for your time, and I hope to